Good afternoon, ladies and gentlemen. In this short video, I'm going to do the problem to prepare you for practice C. So this is on page 109, and it's number 26. So I'll read it, and then we'll show you. I already drew it off on a piece of graph paper. All right, a person walks the path shown. The total trip consists of 4 straight line paths. At the end of the walk, what is the person's resultant displacement measured from the starting point? So let's take a look here. Hopefully it's big enough. We're going to start here. We have 100 meters east, and there's even here the cardinal signal sign, so you can know north is up, south is down, and this spells wheat. So first, we're going to walk 100 meters to the right. Then we're going to go down, because of the arrow looks like it's down, 300 meters. Then we're going to take an angle kind of southwest for 150 meters, and this would be 30 degrees. What was that? That 30 degrees would be south from west. If west is that way, going down south. So 30 degrees south from west for 150 meters. Then we're going to take another angle and go in the northwest direction for a total of 200 meters. The 200 meters now is an angle of 60 degrees, and this 60 degrees would be what? It would be north from west. This way, it'd be north from west. And that way is 60 degrees. Okay, so what is the total resultant displacement? So the yellow here, I already highlighted my book here, is the resultant displacement, but what you can't see is the direction of the arrow. Now, I assumed we started with the 100. I don't know, maybe in your book. Yeah, I can't really tell. But I assumed we started to the right. Yeah, you can. So we start where we started and we end where we ended. Oh, okay. So I'm seeing I did it the wrong way in my. Anyway, so we started here and we ended here. So here is the arrow, should be like so, for the total displacement. We started here, and all we really displaced was down to here. An example I give you guys is, let's say you went on a hike, and when you get to this part right here, let's say you're going around a lake. That's why you didn't go this way. Maybe it's a big canyon. You're not going to tell the helicopter to come save your person the directions you took. You're just going to say the magnitude and the direction. So you're going to have to pick an angle, either this angle here or this angle here. All right, so how do we do that? What we're going to do is we're going to break up the vectors. So I drew this in a bigger piece of paper, like so, right here. Oh, maybe I got to zoom out. Move my book out of the way. Let me zoom out. There we go. Okay, so here's my vector. I decided first you went 100 meters. I didn't decide. It looks like it from the way they drew up the arrowheads. And then you went south 300 meters. Then you went southwest 150 meters with a 30-degree angle, and then you're going to go northwest 200. So the question is, what is the direction and magnitude and direction of the resultant vector? So if we started here, we're going to end up here. That is our resultant vector. I don't know if you can see the arrowhead. Maybe I'll fill it in. There's the arrowhead, okay? So how do we figure out exactly how this is and how long this is? The magnitude and the direction. Well, what we're going to do is we're going to break up each of the vectors into its components. So what I like to do is I'm going to call it a tally. Hopefully you guys can still see. I'm going to tally this up. I'm just concerned we're running out of space here on the paper, but we'll see if this works. Okay, I'm going to say X, all the X components and all the Y components. Okay, X and Y components. So let's look at the first vector right here. This vector is 100 to the right. So this vector is exclusively an X component, shall we say. There's no Y component to this vector. So on this here, I'm going to say plus 100 meters. And it's 0. Nothing in the Y direction. Okay, this is supposed to be a Y. All right, let's look at the next one. This is my second vector. In this one, I'm going down. So I see that the magnitude is 300, but because I'm going down, I know the direction is negative. Now this is in the Y direction, and this vector has no X component. No x component. So let's go over here. This one is going to be minus 300 meters, and it's zippo, zero, nada, nothing in the x component. All right, now let's look at something a little more interesting. This vector right here, that's the one we want to know. What is the x component? We'll put it here. And what is the y component? We'll do it here. And we'll do the same thing for this one. Then we'll add up all the x components, and we'll add up all the y components. That sum is going to be the total components, the x component for this resultant vector. All right, so anyway, let's continue. Here, I'm going to zoom in for you guys. The reason I drew it to scale is just so you guys can see. Here's this vector that I'm interested in. So I'm like, well, gee, where is the x component? Where is the y component? Well, now I can draw the triangle either place. I can draw the triangle for its components. I can draw it here, or I can draw it here, either place. All right, so I'm going to draw the one just because of the 30-degree angle. If I did it down here, I'd have to make this 60, which is fine. You can do that. But I'm going to go ahead, and since it totals 30, we'll use that one. All right, this one and this one. The paper blue is so dark, I don't know if you can see it. Not really. That's why the arrow heads. Okay, so this vector goes down. So I know that the y one must go down as well. Okay, that one's going to go down. Going down that way. And this one, the x direction is going to the right. Because if I move this one over, then when I add up this vector plus this vector, let me draw the other way around here. If I draw this one, okay, this is going down. Oh, I see my problem. All right. So the x component is going to the left. There we go. Now you can see it. So this vector, we'll call it A, plus the one going down, B, gives me this resultant vector. Start from the start, end with the end. Okay, good. That's going to tell me the magnitude of this one's going to be negative. The magnitude of this one's going to be negative. So how big is this one right here? Let's see. Do you need me to draw another one? I'm going to draw this one all by itself, but not to scale. Let's draw it not to scale. I'm going to go like right here, just so you guys can see it. We're going to make this one blow it up right here. This one's 150. All right, so if that's the case, oh, I'm going to be consistent here. One this way and one this way. All right, can you see that? This one's going, the horizontal one is going to the left, and the vertical one's going down. So I know that the horizontal component's going to be negative and vertical is going to be negative. All right, so here's 30 degrees. So if my hypotenuse is 150, you might want to refer to the other video where I went over the sines and cosines. I know that this guy here, that one's right across, so I right across is the sine one. That one's 150 sine 30. So the x component, I'm sorry, the y component of this vector is 150 sine 30. So I'm going to take that, and I know it's negative because it's pointing down. So 150, the y component one is minus 150 sine of 30. Minus 150 sine of 30. Okay, and what about the other one? Well, if this one's 150 sine of 30, then this one is negative 150 cosine of 30. Okay, so we're just working on this vector. All right, so this one over here is going to be negative 150 cosine of 30. All right. So let's do the last one. The last one. That was our third vector. Here's our fourth one. This one's number 3. This one's our fourth vector. Okay. You have to be able to recognize the components of this vector. Let's see. They gave us the 60 down here, so I'm going to go ahead and write in so you guys can see its component vectors. One is this way, and one's going up. One's going up. There we go, down there. Okay. So this vector is pointing up. So therefore, my y direction one also is pointing up. It's going to be a positive magnitude. But the horizontal one is pointing to the left. So I know the magnitude has to be negative. So hopefully this is big enough that you guys can see. The 60 is opposite to this side. So this one's going to be 200 sine of 60, and it's plus 200. That's the y direction. Let's put it up here. plus 200. Oh, I wrote it wrong. It's sine of 60. Sorry, this is sine of 60. Oh, it does say sine of 60. It's 200 sine of 60. Should keep my glasses on. Okay, and this one here on this side has got to be the other one. It's negative 200 cosine of 60. All right, so we have negative 200 cosine of 60. We're going to add these two columns up. And I'm going to go ahead and zoom it in so you guys can see. Now, oh, you can just do it like that, I suppose. Let's just do it like that. Normally, I figure out what it is and write the number in, so maybe that'll be easier. Let's do that instead. All right, let's see what 150 times the sine of 30 is. That's 75. So this one here, I'm going to write it here, is equal to negative 75. Negative 75. Now let's do the other one on the other side here. 150 times the cosine of 30, right? There we go. And we have negative 129.9. So this guy here is negative 129.9. Sounds good? All right, I always like to do a couple extra, but it's still 0. Doesn't even go to 1. All right, so the next one, let's do 200 sine of 60. 200 times sine of 60. I think 60 is just a half. Nope, it's the square root of 3 over 2. All right, so that one is 173. I'm going to put it underneath here. 173. That one's a plus 173.2 on that one. And the other one, 200 times the cosine of 60. Maybe that one's a half. Yep, there we go. So cosine of 60 is 1/2, so times 200. So this one's going to be negative 100. All right, so that's kind of messy. So I'm going to rewrite them all. Okay, so in the X column, what do we have here? Next column, we have plus 100. We have 0. We have, put my glasses on here, negative 129.9, and we have minus 100. Okay, those are the ones we want to add up. And that'll be the X component of the resultant vector. So what do we have here? 100. Oops, can't see. 100. I'll put it over here. All right, 100 minus 129.9 minus another 100. Oh, silly me. I should have recognized that the 100 and the 100 would cancel out, and we just end up with the negative 129.9. Okay, negative 129.9 is what we get for the X component, meters. All right, see if we get that on the other side. On the other side, I've got 0. I have minus 300 meters. I have negative 75 meters. And lastly, I have 173.2. Positive 173.2 meters. All right, so let's add up those numbers. Let's see. I'm going to do 173.2 minus 75 minus 300. That works too, right? Oop, you can't see. It doesn't matter what order I add them all up in. I just did this one plus this one, which is minus, plus this one, which is minus. All right, what do we get? We get negative 201.8 meters. So now I know that they're both negative, negative 129. It kind of makes sense because if we look at here, unzoom here, we look at our resultant vector is going down and to the left. So let me go ahead and draw in the components. Here's my horizontal one, which goes to the left. And here's my vertical one, which goes down. So if I add this down one and add it to this one going to the left, now I get my resultant vector. Okay, so I know that this one here, the X component, the magnitude is 129.9. And I know that this one is 201.8. This one is 201.8. So now all I need to do is do the a squared plus b squared equals c squared. So this one right here, the resultant vector, the magnitude of r is going to be the square root of 129.9, square that, and the other one, which was 173.2. You'll notice that's exactly what, oops, sorry, 201, sorry, 201.8. I was gonna say, that's why I leave it always in my calculator, because that's one number I don't have to retype. So now I can say, give me the square of that, and plus, what was the other one, 129.9. Give me the square of that. Now, yes, you could do this all at once with the square root sign, but I don't usually. There's that number. Okay, it's a big number. Now I want to square root it. So I go second, square root, second, answer. And I get 239.99. Oh, it's pretty close to 240, huh? So we're going to say 240. So this is equal to 240 meters. All right, 240 meters. Now, we're not done. That is just the magnitude. We have to pick an angle. Remember, you're going to tell the helicopter pilot how to get there. So you have to pick an angle. You can pick this one, or you can pick this one. Does it matter? No, one's going to be, let's see, this one would be south of west, and this one would be west of south. Okay, so it depends on which one you're going to give. Let's pick this one, the theta, only because I can do the tangent. Well, you can use any of them, sine, cosine, or tangent, but we've got these two numbers. I'm going to use a tangent. So let's see, where can I put this here? I'm going to put on this side. The tangent of theta is opposite over hypotenuse. Here's my opposite, 129.9. So tangent of theta is 129.9 divided by 201.8. 201.8. All right, so theta must be, let's do that, a calculator. Okay, clear. Let's do arctangent. Arctangent, and what did I say, 129? Yes, it would be 129.9 divided by 201.8. And I get 32.77. So let's say 32.8. 32.8. 32.8 degrees. 32.8 degrees would be this one right here. So that would be from south. So west of south. West of south. So there's my angle, and here's the magnitude. Okay, so let's go through this again. Make sure you guys see what I did here. All right, so bottom line. We figure out where we end up, and then we draw the resulting vector. But then the resulting vector, maybe you can't tell exactly what the dimension is here, because you don't know exactly how much from the 300 it is. So what you have to do is break each of these vectors, the first one, the second one, the third one, the fourth one, into its components. So I'm going to show you the one I did because it looks a lot neater. This is the one when I was preparing for it. But I thought it'd be better for me to draw you a bigger picture. Maybe it wasn't that smart. So here we go. It was 100, and then 300, 150, and 200. So notice how I break up my X components and my Y components of each one. In this paper, I had room to put the actual answer to the left and to the right. That was probably wiser, a little neater, right? So first one only is an X component, no Y component, so it's 100 and then 0. The next one's only a Y direction vector, so there's no X component, so I put negative 300 here and 100 here. This one, I went, too small, so I drew myself a bigger one, okay? Drew myself a bigger one, and I see that the hypotenuse is 150. The one opposite to the angle is 150, sine of 30, and I knew it was negative. So I put in the Y, negative 150 sine of 30, which ended up being negative 7.5. All right, and the other direction is negative 150 cosine of 30. There it is, which is negative 129.9. And then this one, I guess I decided I had enough room and I can see from the 200 and the opposite to the angle, that's the sine one, that's 200 times sine of 60. So that's in the Y direction, 200 sine of 60, which I wrote down as 173.205. And likewise, the other one, negative 200, cosine of 60. You have to know the sign of your vector, and that's exactly why I wanted you guys to know how to break down the components. So once I have my sum of my x component and my sum of my y component, that's what goes into the Pythagorean theorem inside the square root, and I got my magnitude. And for the direction, same thing here. I put in and I got, and this time I described the other angle. So I drew the other angle. And so in this case here, oh, I wrote both of them actually. I did them both. One is west of south and the other one was south of west. All right. So make sure you pay attention to the directions of where your angles are going. And so I'll see you next time. All right.